here tonight. Big thank you to Brent and Ski Tech. Really appreciate the support that you've shown us over the years. Yeah, it's really great to have such great local connections with the businesses here, and everybody in this valley does a lot for us, and we couldn't do what we do without you guys. So thanks so much for that. As a reminder, this is me sitting in a room talking to my computer, which is not necessarily the most ideal way to interact with people, but that's just where we're at right now. If you have a question, if you have a thought, if you feel like asking me something, I highly encourage you to raise your hand and do it live, or type something into the question and answer box. These are a lot more engaging and a lot higher quality presentations if you're willing to interact a little bit. Otherwise, it's just me talking to my computer in my room. So yeah, with that said, we're gonna try a couple of polls here tonight. First one here is just to get a little background on who's watching and how you like to play in the mountains. So I'm gonna launch this thing, and I think you should see some questions there on your screen. If you feel like answering those, why don't you hop on there and do it, and we will continue along in the meanwhile, I think. All right, so yeah, tonight I'm going to talk to you about avalanche forecasting. Avalanche forecasting is very complex, and it covers a very wide range of different activities. What we do at the Sawtooth Avalanche Center is we issue public forecasts that are geared towards people who live and recreate here in South Central Idaho. There are a lot of other types of avalanche forecasting. There are avalanche forecasting for ski areas. You can do avalanche forecasting work at mines, or for industries, for highways, for guiding operations, all sorts of different things. But what I'm going to be talking to you tonight is about the type of avalanche forecasting that we do here at the Sawtooth Avalanche Center. A couple of goals this evening. Hopefully I can accomplish some of these. We'll see how as the evening goes along, if I do or if I don't. But, you can be the judge for that. My main goal is to give you a bit better sense of what we do here at the Avalanche Center, and to help you to understand what you read when you're reading the forecast. Our Avalanche Forecast is our primary product. It's what we put together and spend most of our time and most of our energy on. We have a lot of other things that we do as well, but the Avalanche Forecast is really the bread and butter of what we do. Another thing I like to do is help you to generate a bit better sense for what you're seeing in the backcountry. We spend a lot of time in the snow, looking at the snow, feeling the snow with our hands, with our probes, with our poles, with our sleds, with our skis, performing snowpack tests, all sorts of different things. And we want you to be doing these things as well. Some of them are really specific to the line of work that we're in, and to generating the Avalanche Forecast. And some of them are things that you can do yourself to help yourself with your own personal avalanche forecast. Like I said at the beginning, there are different scales of avalanche forecasting, different types of avalanche forecasting. And really, when you're out in the mountains, when you're going out in the mountains, you're generating an avalanche forecast for yourself. You're basing that often on maybe what we're saying, or what you're hearing, what you're hearing from folks who have been out and about, all sorts of different things. But at a certain point, you need to be able to generate that forecast for yourself. And the other, as part of that, I'd like to help you build a bit of a framework that you can hang some of the experience that you're getting in the mountains onto. It's really easy to go out in the mountains and maybe not pay that much attention, or not see things that we're not looking for, not even know what we're supposed to be looking for. And we come out of experiences in the mountains, and we don't necessarily have a lot of feedback. We don't know what we saw or what we didn't see, and we don't know how to build that into our understanding of the backcountry environment. So hopefully some of what I talk about tonight will help you with that. All right, well, without any further ado, we'll spend a little bit of time talking about what's going on in the backcountry right now. The kind of the flow of this presentation will be to spend a bit of time talking about what we have going on in the backcountry, how we've interacted with that as the Avalanche Center, and how we're talking about that in our Avalanche Forecast, and then kind of tie that into the forecast that you're reading. So our current conditions, unless you have been living under a rock or don't live in this area, you know that we've been seeing a lot of snow lately. We're coming off of nearly a month of steady snowfall. We've had a few breaks between storms, and this last storm that just ended kind of missed our southern areas. So the good folks of the Wood River Valley got a little bit missed on that one, but we're still sitting at, if you look at the map on the left there, we're as a basin, the Big Wood and the Little Wood have 140% of average. The basins that contain our northern areas have closer to about 125%, but individual stations in those areas have 140 to 160% of average. So we're sitting well over average. We started the year well over average as well. We had those big storms in October, basically one big storm at the end of October, and that rocketed us way up until we were well above average, and then it went high and dry. And so the snowpack and the amount of snow in the mountains, the amount of water in the mountains, just kind of flatlined. Over the span of a month, we went from being well over average to well below average, maybe 70 or 80%. And then with these series of 3 big storms that we've seen, we're now back above average significantly. Here's a look from today at 4 different snowtail sites in our area. Galena Summit on the upper left. I assume most folks know where that one is. Vienna Mine in the lower left. That's out near the headwaters of Salmon. Banner Summit. That's up towards the northern end of our forecast area, a bit north of the Sawtooth. And Chocolate Gulch, which is down in the Wood River Valley, just a little ways north of Ketchum. What you're looking at in these graphs, that green kind of smooth line in the middle, that's a moving 30-year average. So if you took all the last 30 years and added them together, divided them by 30, you get this kind of smooth curve where average is. And so when I was just talking about what percent of average we're at, what I was describing is what percent of that moving average we were at. And if you look at any of those individual lines, you can see that they, like in the upper left there on Galena, you can see that it has these big spikes where it's climbing a lot. Those are periods of storms. And then these big flat lines where it's not climbing. Those are the periods in between storms. And as you can tell, if you kind of picture that pattern I just described, where we had well above average snowfall towards the end of October, and then found ourselves to being back to average or even a bit below average, that's where that black line, which is the current season, intersects with that green line. We have that big flat line. You can see it in all 4 of those graphs, and then we rocketed back up again through the month of December and into January, and now we find ourselves well above average. For a little bit of a historical perspective, that upper kind of light gray shading, that light gray line, is the maximum snow water equivalent. So the amount of water in the snow that's on the ground, the maximum over the past 30 years. You can see that in none of these are we actually that close to the maximum. In a lot of these, there have been times where there's twice as much water in the mountains as there is now. So that's always interesting to think about, kind of the range of possibilities that you might encounter in the mountains, and how this year fits into that. Those storms brought us a lot of snow, brought us well above average, and brought some pretty fantastic skiing and riding conditions. Both of these photos were taken in the last week, up in areas north of the pass. Clearly, on the left there, we're in the middle of a storm. It's absolutely dumping, skiing some great powder. And on the right, we're enjoying some of that actually faceted snow that's forming on the surface. You can see kind of those dry puffs of snow coming out from the sled there. That's Chris, one of the other forecasters there on the sled. He's probably the one of us who's best at sledding, and he promised, or he made me send him more photos of this because he wanted to be sure that everybody knew that he didn't just fall over at the end of this turn here. Those storms particularly the latest one, well, all of the storms that we've seen have brought a pretty significant avalanche activity, including leading up to this latest storm and through the storm. This is a photo that I took a couple of days ago. This is up near the headwaters of the fishhook drainage in the Sawtooth. This storm brought 4 to 5 feet of snow up in this area. Down south, unfortunately, only picked up about a foot of snow, but up north here, we are seeing 30, 40, 50 inches of snow over the span of about 5 days. We saw a lot of storm-related instabilities because of that. Lots of loose snow avalanches, lots of small wind slaps, things like that. And then we saw a pretty good number of these wider avalanches, like the one you can see on the screen here. This slide, that crown spans about 1/4 of a mile. It's about a couple of feet deep. It occurred in a heavily wind-loaded area, as you can see. This is at the head of that drainage. So heading off to the west, you just have a huge amount of terrain where the wind can pick up snow and throw it over in this direction. And just based on the nature of this crown, you can see how clean and crisp and smooth it is. You can be pretty certain that it failed on some sort of prominent weak layer. It's on an east-facing slope, about 9,500 feet at the low end there, and 9,900 feet on the upper end. And the weak layer that this failed on, based on field observations, on slopes that directly face the sun, we're seeing crusts with facets. And as we get around to the margins, we're just seeing more facets. There's some southeast facing terrain on this slope, got a little more sun, and some east and northeast facing terrain that just had those facets. But clearly that layer was weak enough to create some pretty sizable avalanches. We've seen dozens of slides like this across our forecast area, kind of focused on those sunny aspects where you have crusts accompanied by facets. I'll get back into this in a little bit, but one major thing that we're doing when we're forecasting for avalanches is looking at the snow surface. And this seems a little bit counterintuitive. You might think that all we do is dig down into the snowpack and we're digging pits and looking at the snow that's already on the ground. And we do spend quite a bit of time doing that. But we're not avalanche reporters. We report to you when we see things, but we're avalanche forecasters. Part of the goal is to observe what's on the ground, to forecast what the weather's going to do, and to generate these mental models for how the snowpack will behave when the combination of those factors come together. Another quick thing to touch on here is a quick note on how we name weak layers. So in the professional snow community, we communicate with each other about weak layers by giving them a name. And we name them not like you might name storms or hurricanes or something like that, though that does sound kind of fun now that I mention it. We name them with the date and the date that the surface was buried. So this weak layer was generated by a storm that started on the 3rd of December. So we call this the 1-3. If you're around folks who are spend a bunch of time in the snow, or guides or forecasters or people who are reading our observations in detail, you might hear them refer to weak layers, and that helps us to kind of identify what that layer looks like, and to communicate in a shorthand what we think avalanches ran on, or what we think those surfaces are like, how they're behaving over time, those sorts of things. I think it's a great time to pop up another one of these polls here. We got some good responses here. I guess nothing. We got a lot of skiers and snowboarders, some hybrid tours, some snowmobilers and snow bikers in the mix. And yeah, there's another set of questions for you. This one pertains to what I was just saying about the folks who might talk about weak layers like this, people who are a little more into the snow and have spent some more time on it. These questions are about your backcountry experience, how much time you've been playing in the backcountry, how many days you spend in the backcountry, that sort of thing. All right, so that storm that just came to an end, it created a lot of avalanches. We know it created a lot of storm snow avalanches, storm slabs, wind slabs, loose snow avalanches during intense periods of precipitation. And it also created some avalanches on deeper weak layers in the snowpack. I was just talking about weak layer naming. This weak layer that created these very large avalanches is called 1211 because that was the date that this weak layer was first buried. This is the weak layer that has been plaguing us for the most of the season thus far, and came from the snow that was deposited in October. So we had that big storm that I was talking about, beginning or the end of October, the 25th, 26th, and then that long drought. So the storm, the snow, even though it's called December 11th or 12/11, that is actually snow that fell in October and then sat out for about 6 weeks. In those 6 weeks, when that snow was sitting out, that's when a lot of the kind of the behind the scenes work at the Avalanche Center goes on. It's not just during these periods of storms when we're out and about, and it's not just these periods after storms. We spend quite a bit of time in the lead up to storms looking at the snow that's on the ground. In the early season, a lot of what we're doing is just watching where that snow is. If you remember back to November, it was quite warm and quite dry. We had days hitting almost 50 degrees at 10,000 feet in the mountains. We burned the snow off of many locations, almost all slopes that were tilted up towards the sun. And we also we preserved it in a few locations, kind of shaded slopes, so where the sun doesn't have it's not facing the right direction to really be putting a bunch of energy into the snow, and it's just kind of sitting there cold. And on a lot of slopes at upper elevations, where you're just high enough, the wind's blowing quite a bit. You just don't. It's hard to melt snow off up there. That's where this weak layer exists. That's what we describe as the distribution of the weak layer. And I'll get a little bit more into that in the distribution. That slide on the left, that's a photo I snapped from today. This was first, I think Chris first noticed this when he was out and about shortly after the storm, but because of where he was, he couldn't actually quite pick out that this was a crown. He noticed a little irregularity when he was glassing, but he couldn't tell if it was maybe a cornice or something else, and the light wasn't great. A lot of what we do at the Avalanche Center, and I'll get back into this as well, is to watch how things behave after the storm. So we have this pattern where we're looking at the snow when it's on the ground, watching how it's behaving when it's on the ground, monitoring the surface of the snow, seeing how it's changing with different temperatures or different amounts of solar radiation, sometimes growth of surface hoar, those sorts of things. And then we're also watching to see what happens afterwards. That slide the photo on the right there, that's in Champion Creek, which is in the White Cloud Mountains, just south of the 4th of July drainage. And I snapped this photo yesterday. You can see a couple interesting things in that photo. There's that kind of the major deep crown, and then you can also see, if you look on that right edge there, that there's a couple of sets of crowns. So it appears that this avalanche probably initiated a bit higher in the snowpack, failing on a weak layer a bit higher in the snowpack. Either this 1-3 weak layer, or we also have a few weak layers that were made between storms between the 19th of December and the 24th of December. Those are called, obviously, 12/19 and 12/24. And there's a little sneaky 12/22 in there, but that's not everywhere. You can see that there's quite a bit of complexity in the snowpack, and a big portion of our job is to watch that complexity, is to watch it develop, to have expectations about how it will behave, to go out and see how it behaved, and then to reform our mental model around that. I'll get back into that concept of expectations, observations, and repeat towards the end. That's something I think that you all, as backcountry travelers, can use in your toolkit. So we're out and about, we're watching what happened with that storm, and now we're coming to the present, we're to today. These graphs show snow depth at 3 different locations over the past week. The first bit of those graphs, so as we're looking left to right, we're starting about January 5th, that's in the storm, about a third of the way through where the graphs peak, that's January 8th. That's when that storm was drawn to a close. And then you can see that the graphs just kind of taper off down towards the right end. Excuse me. You can see we lose snow depth, but we're not losing water out of the snowpack. At Banner Summit, the snow depth decreased by 9 to 10 inches over the last 4 or 5 days as that warm air forced the snowpack to settle. Vienna Mine, which was the big winner out of the storm, and you can see actually that straight line in the middle, that's a period where it was snowing so hard that it wasn't able to report how much snowfall there was for some of that. The snow sensor is probably covered in rime and covered in snow and that sort of thing. We lost 18 inches, almost a foot and a half. And even at Baldy, where it didn't snow quite as much, the snowpack has settled over 6 inches over that time frame. If you remember back to the storm, we had that very intense ending to the storm, and then we settled into this period of pretty cold days with really inverted temperatures, 15 to 20 degrees below zero down in the valley. And then that gradual warming leading to today, where we saw mountain temperatures hit the mid 30s to low 40s, which is why I've worn my Hawaiian shirt for you today. And now a little bit of outlook. So when we're as Avalanche Forecasting, like I stated, we're not just looking at what exists right now, though that is a big part of the work that we do. We look back into the past to see how things behave, and forward into the future to see how things might behave in the future. This set of graphs here is a model prediction of how much snowfall we're going to see in the Sun Valley region over the span of the next week. And I must say it's a little bit grim. On those two graphs on the left, the upper one is inches of water. So that's if the snow was falling in the form of rain, or if you melted it, how many inches of water it would be. And on the bottom left there, you're looking at inches of snow. Every single one of those little lines, and there are a bunch of them that are hidden along that bottom there, those are all different members of this suite of models. And they all are run with a little bit different perturbations. So each model is, it asks a bit different question. Maybe this blob of moisture goes here, or maybe the ridge tracks here, maybe the jet stream moves in this direction, that sort of a thing. And so each one is its own outcome, and then you're looking at the average. So the dark green and the dark red lines in the upper graph, and the dark green and the dark blue lines in the lower graph are predictions, are the mean of all the models put together. And then those little squigglies that take off up there to the right are the individual models themselves. So you can see two models, the most optimistic model, and I often look at this when I'm getting a little bit bummed about the predicted snowfall, and I can at least say that there's one outcome maybe we will get this much snow. The most optimistic one is calling for 4 inches of snow in the next week, and all of the others are saying that we'll be lucky to get about a half to a quarter of an inch. So that's a little bit grim. That's where we are. My job, unfortunately, is to just tell you how it is. We don't have a whole lot of control over the weather. There's not a lot that we can do about that. That is how it is. If we zoom back to this set of plots here, we're talking about essentially the snow, the amount of water in the snow that's on the ground. And we can see that big flat line that I talked about earlier, that dry period in November. If we run this next couple of weeks without snowfall, we see that which are the red dots there, we see we begin to approach average snowfall if it stops snowing, or average snow water, average amount of water that's in the hills. So even if we don't get that, we're not in the worst situation, and you can picture, I often like to picture that there are more big peaks in our future. And the optimist in me thinks that if everything goes well, maybe we'll find a way to reset some of that gray line, the maximum recorded, in the next little bit. All right, so that gives you a little bit of a sense for what we do. That gives you hopefully a pretty good sense for what's going on in the mountains right now. Now I want to tell you a little bit about myself. Um, there is a relatively standard set of things that people do to forecast avalanches, but we all have our own different takes on it. We all have our own different backgrounds, our own personal experiences, and so I'm going to tell you a little bit about mine and how that drives my avalanche forecasting process, because it's a personal thing ultimately. I grew up, was lucky to grow up in Bozeman, Montana, the child of two school teachers who loved to be in the mountains, playing and running around, backpacking, hiking, and fishing. We had our entire summers off collectively, so we spent a lot of time running around and camping out and just kind of engaging with the natural world. And I think that background really has played a big role in me being drawn to the world of snow, and to being drawn to doing this professionally as well. When I went to school, when I went to college, I started to study geology, and geology is at its heart an observational science. And geology is a lot about looking at things that you find and trying to answer questions about why they might be there, come up with an expectation of what you're going to find around the next corner, see if that's what you find, and then repeat. It's the same idea of expectations, observations, and repeat. It's a photo from a top secret location here in Idaho. Some coworkers of mine getting up close and personal with rocks, which doesn't look terribly different from the sort of things that we do now. I went to school, like I said, studied geology, began to work professionally in the geology field, doing that work in the summer, and then was just a ski bum in the winter, which is a great combination of things. And at a certain point, I realized that being in the snow and looking at the snow were not very different from what I was doing in the summers. And the more that I spent time directing my attention at the snow, directing my attention at what I was finding on the ground, directing my attention towards how weather patterns played out in different areas, what caused avalanches, what didn't, what made for weak layers, and what didn't. I realized that these two things that I was doing were one thing in a way. That idea of expectations and observations and repeat. I'd go out on a day for work. I'd expect to find this type of rock here, expect to see that this dike swarm continued to this area, only to find it pinched off by a fault. I reform my expectations, and I'd go make more observations to see if they were right. That's exactly what I was doing in the winters in the mountains. And that led me here. This is almost as exciting as looking at rocks, and as you can see in that snowpack on the right, frequently we get to dig down and look at rocks, which is a great combination. Both these photos are from this year. The one on the right, I'm on Morgan Ridge there. That's in early December before the snowfall returned. I'm clearly a little bit dubious about the amount of snow that we've got on the ground. And then on the left, we're starting to stack up some good snow, but that snow on the right that got weaker during that time frame of drought is sitting at the bottom of that snowpack, and that's created a lot of the avalanche hazards that we've been dealing with. One popular misconception that I think a lot of people have about us at the Avalanche Center and about avalanche forecasting in general is that we are the fun police, and that our goal is to just keep you out of the backcountry or to keep you out of avalanche terrain. That we would be happiest if all you did was just never go into avalanche terrain. And I must say that would make our jobs significantly easier. If my entire job was to tell you to avoid avalanche terrain, that's pretty easy to do. I don't have to get up at 3 a.m. and spend 4.5 hours thinking about how I'm going to write to you about avoiding avalanche terrain. I just tell you to avoid avalanche terrain. But that isn't our job. In fact, and I can only speak for myself here, but one of my favorite things to do is to play in avalanche terrain, to recreate in avalanche terrain when it's appropriate. And appropriate means different things for different people. For me, appropriate means that it's a repeatable process, that it's something I can go out and do today, and I can go out and do it tomorrow, and I can go out and do it the next day, with the end goal of returning safely home to my friends, to my family at the end of every day. We're not out there to tell you not to go. We're out there to help you do it safely and to give you the information that you need in order to do that and to help you do that safely. All right, this next slide is a little rough. There's a lot of stuff on here, but we're talking about avalanche forecasting, and I have to talk about this a little bit. I'm not going to dive into any of this in a lot of detail because I don't think that it's that helpful for you, and it's also takes a while to wrap your head around a lot of this stuff. And clearly, there are way more words on here, way more charts on here than you should be throwing on a PowerPoint slide. But here we are, nonetheless. Upper left there, you can see the danger scale. I suspect all of you are pretty familiar with the danger scale. Danger scale is, we assign danger ratings every day, and we assign these danger ratings to our forecast zones. The danger scale works at a certain scale. It isn't a slope-specific scale. We're not assigning a rating to a given slope or even a single given mountain, but it's better seen as an average or a general description across a large area of the danger. And I'll come back to that idea of scale in a second. But avalanche danger is a function of the likelihood of an avalanche and the size of the avalanche. In the upper right there, you can see this chart of likelihood. Likelihood is the combination of where you find something and how sensitive it is to your trigger. I know, a lot of stuff in here. This gets a little boring, but we're just going to power through it. Just a minute or two, and then we'll be done. Where you find something in the terrain, we break that down into essentially, is this only in one spot or in a couple weird spots? Is it in a bunch of different spots, but only these specific spots, or is it everywhere? That 12-11 layer that we talked about earlier, our October snow that's on the ground, that's what we describe as specific, which means it doesn't exist everywhere. It's not widespread, but it's not isolated. It's not just in a couple random places. It's specific to certain types of terrain, and those types of terrain are shaded middle elevation slopes, shaded upper elevation slopes, and a lot of sunny upper elevation slopes as well. The other thing that goes into this idea of likelihood is how sensitive an avalanche is to triggering. We have 4 categories of sensitivity, from unreactive to touchy. Those are further broken down on that chart on the bottom. We're not going to go into all of this, but what's important is to know that likelihood is a function of where you find something and how likely you are to trigger. If you have a really touchy layer, but it's only in one teeny tiny spot, well, it's relatively unlikely that you're going to trigger an avalanche on it. And if you have a really touchy layer, but it's on a ton of different terrain, well, it's actually quite likely, or almost certain, that you're going to trigger an avalanche on it. That's all I'm going to dive into on that. There's a lot in there. It's kind of more than anyone wants to digest. This is kind of our headache and not yours, but I wanted to give you a little bit of a sense for when we're using these words, where they're coming from. They're not just randomly chosen. They're not selected. We choose our words and the things that we say quite carefully, and this is just part of that, part of the framework that leads to that. Okay. Whew. A lot of words, but now we're back to mountains. This is where I feel more comfortable. This is where I feel the most comfortable, is out here in the mountains. And I suspect for you guys, being out here in the mountains is where you feel most comfortable too. Scale is quite important when we're talking about avalanche forecasting. And it's important that you realize the scales that we operate on versus the scale that you're operating on. Or for me, the scale that I'm operating on as a backcountry traveler versus the scale that I'm operating on when I'm avalanche forecasting. So here's this nice little rib here, this little raised rib of snow. looks like just a fantastic ski. I mean, I wouldn't mind being there right now. That's slope scale. That's the turn you're making. That's the idea of forecasting for the tip of your skis. And that's not what we're doing. When we give out a danger rating, we're not saying that the danger is low on this slope or the danger is high on this slope. We're saying that the danger in this forecast area is low or high. We're saying that your likelihood of encountering avalanches, your likelihood of encountering an avalanche problem and its sensitivity, the combination of those factors lead to the danger rating. I think it's a pretty common misconception that the danger rating applies everywhere in specific, and really it applies everywhere in a broad sense. We spend a ton of time thinking about variations across our forecast areas, not necessarily from one slope to the next, but from one mountain to the next, or from one mountain range to the next. We forecast for 4 forecast zones. They're pretty massive areas. We have almost 4,000 square miles of forecast terrain. I think 3,600, 3,700 square miles. These are huge areas, and what you encounter when you're out in the backcountry may or may not perfectly reflect what we're saying in the avalanche forecast. But the goal of our forecast is to give you a sense of what the range of conditions are, what type of terrain you might encounter a problem in, and what type of problem you might encounter in that terrain. I'm not seeing any questions, so I'm assuming that everybody is on top of this and there's 100% clear, no issues. That's great. I'm loving it. All right. We're talking about scale still here. This is just another way to think about kind of that point that I just made. So we're looking kind of northeast here. You can see the Wood River Valley coming in from the right side of the frame, the Salmon Valley coming in from the left side of the frame, and where those two meet, we have Galena Summit. Galena Summit sits in our Galena Summit and Eastern Mountain zone. But Galena Summit is not just that zone. In fact, you can see that the mountains spread for tens of miles in each direction, all the way out towards Stanley in the upper left there, all the way down towards the Pioneers in the lower right, and out Baker Creek in kind of the bottom portion of the frame. If you go and ski on Galena Summit, you're not even looking at that big of an area. You're looking at this individual slope, this one spot that you are, or maybe a few spots in that area. And what we're saying in the avalanche forecast is meant to cover that area and the Galena Summit area and all of these zones. And we're combining the data that we've collected, observations of avalanche activity, snowpack observations from professional users and from users like yourselves and the public, into this single danger rating. And so when you're getting that danger rating, that shouldn't be, or doesn't have to be, shouldn't be the only thing that you're looking at. There's a lot of other information in the avalanche forecast, and that's meant to help you drive where you might decide to go based on where you might encounter problems and what type of problems you might encounter. To give you a better sense for how big this zone is, and again, this is one of our 4 zones. That second arrow there further to the right is pointing at the mighty Durance, kind of where the big bend in the big wood is. Down there at the far right, we're looking at Hindman, the high point of the Pioneer Mountains. So that's kind of towards the southern end of the Pioneer chain. That stretches across left through the boulders, left is northish, and continues up into the White Clouds, all the way to the town of Stanley there. All right, so that's scale. I hope that helps you envision a little bit what the difference between what you're seeing on any given day is and what we're saying in an avalanche forecast. All right, so now let's run through. I kind of want to run through a couple different sequences of problems that we go through at the Avalanche Center and how we deal with those. I'm first going to start about kind of the obvious one, storm issues. You can see here in this photo, it's absolutely dumping and everybody's happy. breaking trail through deep snow, going to ski some great powder. Hard to get a whole lot better than that. We all, you're going out and find a group of folks here, went out, they read the Avalanche Forecast in the morning, they saw what the rating was, they read the bottom line, the avalanche problems, what type of problems they might encounter. Maybe it was a storm slab, maybe it was a wind slab, and now they're out in the field. But they're out in the field on this individual slope, and again, we're describing over this large area what may or may not be happening. Of course, like I've touched on earlier, when we're talking about these things, maybe it's a storm slab problem or a wind slab problem, these aren't just things that we came up with that morning, or these things that we just kind of pulled out of thin air. We spent quite a bit of time leading up to this big storm event, doing what we call a service inventory. And when we're doing a service inventory, we're going out, we're seeing what surfaces we're finding so that we have some sort of idea of what this new snow is falling on. Say at a certain point, this spell of high pressure that we're in is going to end. It may not be until February. Hate to break your heart, but mine's already broken, so might as well be there in the same boat together. But at a certain point, it's going to end, and what the services are doing will be really important. In fact, any given day we're out in the mountains, we're doing this thing that's called a service inventory, that we collectively call a service inventory. I was out today. I think probably at least a handful of you were out today, and it was quite warm. And even though we've been enjoying this cold powder that's been staying pretty good, even on solar aspects, as long as the slopes were low enough angle, we're finding that you start to get to these warmer days like that, and that starts to change. You're seeing on these sunny aspects that surface ore that's maybe been growing on the surface is starting to get cooked down. Instead of having this nice, cold, kind of smooth, slippery powder that we're skiing through and that we're riding through, all of a sudden we're dealing with this wet surface. That wet surface is now frozen. It's dark out there. The skies are open. The snow is radiating out its energy. The surfaces are always changing. So while we're constantly monitoring this, what's really important is what the snow surface looks like right before it gets buried. For me, I spend a lot of time out in the field, and I spend a lot of time monitoring surfaces and monitoring them change. But that's not the only way that we can look at surfaces. We also use these mental models that we have going on in our head, compare those to other folks' observations like yours, and we see what the weather's doing. We can see if we're in a period that's conducive to forming surface ore, if we're in a period where the surface of the snow is faceting, if it was warm enough that crusts were formed, those sorts of things. So we're combining these field observations with these mental models that that we use to help understand the world, and then we're going out and we're seeing how accurate our models are. We're observing things, we're reforming those models, and repeat. Expectations, observations, repeat. So the storm's in progress. We've done our service inventory. We know what it's fallen on. What are we doing now? Well, we're going out into the storm. These can be quite fun field days. Generally, you get quite wet when it's snowing like this. All these fine folks here are probably soaked to the core and seem to be loving it based on their facial expressions. We're seeing how much it's snowing in different places because we have pretty variable snow depth across their areas. We can see, I mean, it's pretty incredible just bouncing back and forth between Stanley and Haley, how different the snowpacks in these two areas can be, and how different the amount of snow falling can be. This last storm was a pretty classic west-northwest flow. Those sorts of storms deliver tons and tons of snow to our western areas, western Smokies, all the way down to Dollarhide, up north through the Sawtooth, all the way to Banner. And then you might be sitting in the Wood River Valley and you're reading the forecast and we're talking about all these storm issues and we're talking about all the snowfall that's happening and you're sitting there looking at partly cloudy skies. And I think that's a great illustration of this idea of scale. It's not, we're not forecasting for a town. We're not forecasting for one place. We're forecasting for these big areas. And when we see these big differences in snowfall, differences in weak layer formation, and those sorts of things that can have a pretty heavy impact in the forecast. And we often put that into the forecast so that you can have some sense for what you're going to find, where you're going to head out. So there we are. We're out during the storm. We're seeing how much it's snowing. We're seeing how much it's blowing. We're recording these observations. We're putting those on our website, on this really snazzy observation platform that we've got. We make all of our observations public. So if you go to our website, click on the observations tab and view observations, you can see where we've been, what we saw there, how much it was snowing, what sort of avalanche problems we encountered, all those sorts of things. So those are a great tool for you. It's also a great space for you to share what you're seeing out there, and that can be incredibly helpful. I'll get back to that. So the storm stops, the sky's clear, and we have a gorgeous sunrise. This is a photo taken on 21st of December, so this is the solstice, and we're looking at the Sawtooth Mountains, just a little ways north of Williams Peak. And we're not really seeing a whole lot. This is at the start of, if you remember, we've had 3 big storm events so far. This is about a day into the second big storm event. So we had the first big round of storms. We saw a lot of avalanche activity, and we had a bit of a clearing, a bit of period of no precipitation between there. We're out inventorying services. We're trying to figure out what things look like, what the next round of storms is going to fall on, and then we're looking to see what happens. This is an incredibly important part of the avalanche forecasting process, is just observing what actually happens. No matter what level of experience we have, no matter how many hundreds of years old we are, we can't know exactly what's going to happen in the mountains. We can know in a general sense, we can have an idea of what type of issues we might encounter in the mountains, but saying that any given avalanche is going to occur on any given slope is way out of the scope of what we do. That's the type of forecasting that someone who works for a highway might do, where they're looking at one avalanche path. They're monitoring a single avalanche path. They're digging snow pits maybe across this path. They know what the surfaces are like everywhere in this path, and then they know how much it's snowing in that path. But that's not the type of avalanche forecasting that we do. We do this big drainage or mountain range scale forecasting, and that's what you're reading when you're reading our forecast. So we have this big storm. Not a lot happened. And then we had a couple more days of storms. And here's this photo of that same location here in the Sawtooth 3 days later, sunrise 3 days later. And what you can see is a number of avalanches. You see this kind of striated surface to the snow that's pretty obvious. Those striations are from loose snow avalanches that are kind of spilling down the slope. You've probably seen photos of maybe mountains in interior Canada or up in Alaska, where you have these steep mountains that constantly get snowed on, and they develop those big spines. Those are these drainage runnels that come from loose snow avalanches continually pouring down the slope when you have these big snowfalls. You can also see up higher on the slope some thinner crowns that are related to, those are probably storm slabs and wind slabs. And then looking a bit lower on the slope, you see some of these deeper crowns, avalanches failing on deeper weak layers. This feedback of what the snowpack actually does when it actually snows on it is the most important thing. It's the most important observation for you to be making when you're in the backcountry, and it's the most important observation for us to be making, because this is the real world. Our mental models may say that no avalanches are going to happen, or that avalanches are going to be breaking all the way to the ground, or there's a wide range of what your model might say. But when you get to reality, that's where the rubber meets the road, and that's where it actually becomes the most important. So we have these expectations that we develop. We make these observations of what actually happens, and then we readjust our model and we go forward. All right, so that kind of takes us through how we're dealing with storms. Now I wanted to take a step back and look at just over a little bit longer time scale, how snowpacks might evolve over time a little bit. And I'll take you through an evolution that we've dealt with and are continuing to deal with in our area, and kind of differences across the area right now. So we've got these big storms. Storms have thrown a bunch of snow at the snowpack, and they're burying layers. When we get these buried weak layers, weak layer can be quite short-lived. Maybe it's only a problem for 6 hours or 8 hours or something like that. But we can also bury weak layers that are problems for days and weeks and months, entire seasons. Last year we dealt with the weak layer that we worried about all season long down in our southern areas where the snowpack remained thin. That's not terribly uncommon around here. When we generate this weak snow near the ground, and we bury it, but we don't bury it that deep, and then we don't load it that much. We have these persistent weak layers. The avalanche problem is a persistent slab problem, and those can plague us for the entire season. As Scott likes to say, I'll trust that snowpack when it's going down the river, and that's how it can be around here on a number of years. But that's not the only route, and the optimist in me is hoping that we don't necessarily have to go down that road this year. We've seen, particularly with this last storm, we're seeing the conditions in our area start to diverge quite a bit. Up north, as I described, that last storm, gave us 3, 4, 5+ feet of snow, and down south, we got about a foot around the Wood River Valley over the span of 5 days. What you see because of that is the snowpack is drastically different just in terms of snowpack depth, and the burial depth of a weak layer is drastically different. So we have this progression from storm slabs or storm related problems. We bury this weak snow, and we have this persistent slab problem where the weak snow is still pretty close to the surface. It's pretty easy for humans to trigger. It's pretty easy to go out and about and trigger an avalanche like this, even from below a slope or from the side of a slope. What's called remotely triggering. And then we keep putting more snow on it. It makes more avalanches, but it doesn't avalanche everywhere. That snow is still buried in our snowpack, and the slab on top of it gets thicker and thicker and thicker. Then we're trending towards this deep persistent slab problem. The deep persistent slab problem is a tough one to deal with. As avalanche forecasters, it's a tough one to deal with as backcountry travelers. During storm events, it's snowing really hard. Big avalanches are happening just in the new snow. That's easy. Just stay out of the way. You're dealing with persistent slabs. It becomes harder to trigger these things, but they're still behaving in pretty spooky ways. Really not that hard to convince yourself that maybe you don't want to be in the kind of terrain where you might find those things. And then you trend towards these deep persistent slabs, these deep slab avalanches, and they become hard to trigger, and they become less frequent. You're not getting any direct feedback from the snowpack. You're not walking around and getting cracking and big extending cracking or big collapses where you can feel the snowpack actually dropping into that weak layer. In fact, you may have no idea that it's there at all if you don't dig down to it. This is a tough problem to deal with. In the right circumstances, you just keep putting snow on it. That snow leads to mechanical compaction of that weak layer. The slab above is just so heavy that it's kind of squishing the weak layer, and you're also getting much friendlier temperature gradients. So instead of having conditions in the snowpack where the snow just wants to stay weak, it's not really being forced to change into a more rounded state. It's just staying as facets in a general sense. You bury it, it's forced to change, it gains strength, and eventually the likelihood of triggering avalanches on that becomes quite unlikely. And at a certain point, it kind of fizzles away and goes off into the night. Deep slab problems are hard to deal with. what do you do when you know that it's unlikely that you're going to trigger an avalanche, but that there's a possibility, and that you can't really calculate what that chance is? Maybe it's 1 in 1,000, maybe it's 1 in 100,000, and you don't know. And regardless of how many pits you dig, or how many times you pull probe down to the weak layer and feel it, or how many times you dig down to it and you look at it, how many stability or snowpack tests that you're doing, you just don't have a great idea when it's safe and when it's not safe. And at a certain point, your best recipe in that sort of instance is time. You just have to give it some time, and what's important is time without a loading event. And that's kind of the stage we're in right now in a couple of our forecast zones. We went to a deep persistent slab in the banner zone a little over a week ago. The slab there is quite thick now and quite hard. Chris and I were out yesterday, looking at 2 days ago, looking at slabs, digging down and looking at that weak layer. We saw that the weak layer appeared to be gaining a lot of strength. The facets, those kind of cups and chain depth ores, those really angular pieces of snow, the edges were kind of coming off those little striations on those cups of snow were beginning to disappear. You're seeing rounded bits on them. They're kind of more mashed together. You can't just pull out a weak hand of that sugary snow, or a weak handful of that sugary snow and shake it back and forth. All signs that you're heading in the right direction. But at the same time, you have this terrible snowpack structure. Maybe some of you saw the video that we made when we were out there, or a photo from it, where I'm standing in a pit that's almost 3 meters deep. It's almost 10 feet deep. That layer of weak snow is 6 to 7 feet thick. And I'm standing near the ground, and the snow pit is just towering above me. That's what those deep resistant slab problems look like. Now, as we travel south in our forecast areas, we know that the thickness of that slab decreases. And while we have these boxes that we put these things in, these wind slabs, storm slabs, persistent slabs, deep resistant slabs, the world isn't really black and white like that. It's just all sorts of shades of gray. And the transition from a persistent slab to a deep slab, or the transition from the point where you're calling something a deep slab to not talking about it all, is also shades of gray. And that's, we spend a huge amount of time at the Avalanche Center thinking about what's going on in the snowpack, and then thinking about how we can best communicate that to you. We have a pretty interesting job in that a huge portion of our job is looking at the snow and thinking about what the snow does. But another huge portion of our job is public risk or public danger communication, is trying to tell this audience, tell a much wider audience, what it looks like out there, what sort of problems that they need to be on the lookout for, how likely they are, and how to keep themselves safe in the backcountry. For you in the backcountry, there's a few different things, or for us in the backcountry, there's a few different things that we're doing that I mentioned. Those snowpack tests, those are quite effective when the slab is thinner and the weak layer is closer to the surface. They become less effective over time. We're looking at the hardness of that weak layer. That's a pretty good way to gauge over time, but it's also quite difficult to dig down to the weak layer over and over and over. And that there's a high degree of variability from slope to slope. So it's not necessarily a perfect data point. But those are the sorts of things that we're doing. And then most importantly, we're monitoring for avalanche activity, because that's the feedback that tells us, seeing an avalanche clearly tells you this layer is capable of producing avalanches. I showed you those couple of slides in the beginning, those big slides on Imogene Peak and the big one above Champion Creek and the White Clouds. Those are clear signs that these things can make avalanches still, that it's not healed, that it's not over, and it's not to be written off. All right, I think I got one more poll for you here. All right, this one's about reading the forecast and different ways that you engage with the forecast. We'll launch into that one, and then we're kind of heading towards winding some of this down. All right, observations. Observations they're the backbone. They're the backbone of what we do at the Avalanche Center. They're the backbone of the forecast that we create and that you read when you go out into the backcountry. There is a huge range of observations. We're generating our own observations. I'm out in the field, I'm walking along, I'm seeing what the surface looks like, I'm digging a snow pit, I'm doing my snowpack tests, or I'm walking along with my probe out and I'm seeing how deep the snow is, how thick the slab is, how hard it is to push through the slab, looking for avalanches, those sorts of things. We also have remote weather stations, which are hugely important, and they're another data point, another observation that we use. They're telling us temperature, they're telling us how high the wind's blowing, how strongly the wind's blowing, which direction the wind's blowing from, snow depth, the snow density, amount of water in the snow, these sorts of things. And then we also have your observations. And the observations that we receive from folks are hugely important because there's only 4 of us. We don't work 7 days a week. We're not out in the fields as much as we'd like to be. We can't be everywhere at once, and we've got 4,000 square miles to cover. It's a big area, and even with our observations, what we can see, there are just huge holes between these points of where we know what's going on and where we don't know what's going on. And we use the mental models that we've built of what the snowpack is doing, our understandings of weather patterns, and these sorts of things to fill in those gaps. And there will always be gaps because regardless of how many observations you have, there's always going to be gaps in between things. But the more observations that we get from you, the better off that we are and the better off that you are. And I've talked to a lot of folks who, in fact, I bumped into a gal today who mentioned that she hasn't seen anything, so she hasn't submitted any observations this year. And I think the interesting part about that is that of course if you're in the backcountry, you're seeing things. There's no way to not go out into the backcountry and not see things. You're seeing all sorts of things. You're seeing new snow, you're seeing avalanches or not, you're seeing if the wind's blowing or if it's not, you're seeing how much snow you parked in versus how much snow you found up high. You're seeing how good the skiing and the riding are, all of these sorts of things. And part of our job at the Avalanche Center is to take any sort of observation like that and incorporate it into this mental model that we have and into the collective mental model that we keep running at the Avalanche Center. It's easy to think that you're not seeing anything. And when you think that you're not seeing anything, I'm pretty confident that you see less things. If you spend the time to even say to yourself, oh, this is how much snow there was at my truck, and you take out your ski pole or your snow saw or whatever you have, I like to carry a little measuring tape in my pocket, a little sewing measuring tape, a little retractable deal. That's a fantastic observation. That's incredibly helpful for us. Other observations that are incredibly helpful is how deep is the snowpack where you are. You're out and about and you got stuck on your sled. Of course, I would never do something like that. But you get stuck, you dig your track all the way to the ground, and you gotta, dig a massive pit just to get yourself out and get yourself moved around and pointed in the right direction. You know how deep the snow is. That's a fantastic observation. In fact, like I was talking about that deep slab, persistent slab to deep persistent slab transition, like that can be incredibly helpful, just knowing how deep the snowpack is in the area that you're at. Avalanche activity, that's kind of the bread and the butter. If you ever see an avalanche of any variety, that's incredibly useful for us. It doesn't matter if it looks old. It doesn't matter if you can't say anything about it. You don't know anything about it. if you shoot a photo of an avalanche and send it to us, I guarantee you we're going to be pretty excited about it, and we'd be happy to answer any questions that you have about it. We spend a lot of time looking at the snow, thinking about the snow, and looking at avalanches. We have a pretty good sense when we see an avalanche. You know, we know what way the slope faces, how deep the crown is, how filled in the debris is. All those things tell us quite a bit about the snowpack where you were and that it was capable of creating an avalanche. Wind, super helpful. Was it blowing? Was it blowing when you got out of your car? Was it blowing all the way up? Was it gusty? Was it steady? Was it just, you know, ripping the snow off all the way to Montana and Utah, or was it just kind of slowly sifting it in? Incredibly helpful. And a lot of folks kind of miss this one. Just how good was the skiing or the riding wherever you were? Just like with an avalanche, a photo of an avalanche, we can tell a lot about what's going on just based on the ski quality you had or the riding quality you had. If it was bottomless, if your track was sinking into the ground all the time, if you started on one slope and then all of a sudden it got wet and sticky and so you moved to another one, any of those things are really helpful for us. One thing to think about when you're making observations. So you've taken this step where you're going to make these observations. Is what you're seeing all that there is to see? Are you seeing the entire world when you're looking out, or are you just seeing a piece of the world? And this is something that we frequently have to remind ourselves of. We go out into a drainage, and you know, you're in this big drainage, you're looking around, spending a bunch of time looking at everything, and it feels like you've seen everything. But you turn the corner, and then all of a sudden there's something that you hadn't seen before. You know, you climb up a ridge line, and all of a sudden you're seeing a bunch of terrain that you hadn't seen. I had this experience yesterday. I was out in the White Cloud Mountains, out in 4th of July Creek drainage, riding out on the road, and the visibility was okay. I mean, I could see a long ways, but the light was a little bit flat, and kind of looking for crowns in a few places, and not seeing them, and you know, looking for more and not seeing them in other spots. You kind of start to, easy to think, it's like, well, can't believe there's no avalanches out here. Hopped off my sled, climbed up onto a high ridge, and pulled out my camera, got a long lens on my camera, and just started blasting around, just looking at what I could see and shooting photos. And I started to pick out one crown, and then there's another crown, and then there's that big avalanche I showed you that photo of the beginning of. And all of a sudden that model changes a little bit. And it's easy to get sucked into this mindset of what we're seeing is all that there is. And instead of reminding ourselves that what we're seeing is just what we're seeing, and there's all kinds of stuff that we can't see. My brother came and visited recently. He's an attorney, and he told me, I was talking about this a little bit. He told me an interesting story about when if you're an attorney and your client's being deposed, they might show you a photo of a house, and you're looking at this house, and they say, well, what do you see here? And you might say, I'm seeing a blue house. And a good attorney would respond to you, no, you're seeing a house that has one wall painted blue. What you're seeing is what you're seeing, and your observations are powerful. But what you're seeing is not all there is. What you're seeing is a fraction of everything that there is to see. This is definitely something that we have to spend a lot of time reminding ourselves internally of, that we can see what we see. We have these data points. We build these models, but our models aren't the real world. Our models are a working set of assumptions, or a working set of explanations for everything that we've seen, and we have to constantly update those models as new information comes in. And this is incredibly important for you as a backcountry traveler. When you're going out, it's the same idea. You've got a framework for what you're expecting to see. That's built on maybe the previous days you've had in the mountains that year. Maybe it's built on what your friends saw the day before. Hopefully, it's at least in part built on what we're saying in the Avalanche Forecast. And then you go out, and what you see might be different. And it's important not to think that that what you're seeing isn't real or what you're seeing isn't true. You must incorporate that into your mental model, update your model, figure out how to explain why what you're seeing is so different and what that means about what you're thinking about snowpack stability, what you're thinking about what you're going to ski, what slope may or may not be appropriate, how sensitive a weak layer is, how reactive a weak layer is to your weight, to the weight of you on your sled, all those sorts of things. So you've got your model, you've got your expectations, you go out into the backcountry, you're making these observations, you're updating your model, and then you're repeating. And that brings us to the end of the presentation. So I'd love to, open this up to as many questions as you guys have. I'm happy to talk about anything, preferably related to avalanches and forecasting and any of those sorts of things. But any questions you guys have about the snowpack right now, about anything like that, just fire away. We'll see what we get.
We'll start you off with a good question here, Ben.
All right, let's hear it.
I'm back to moderate. All right, Brian has a question for you. What is the average number of observations you get from the public, guides and or other?
Yeah, great question, Brian. We were lucky enough to have a number of really tuned in guiding companies here in the Valley, and they are very, they do a great job at submitting us observations. I'd say on any given day, there are 3 main companies on any given day. We're getting an observation from each of them or multiple observations from each of them. Public observations, it really varies kind of from day to day a little bit. You can tell that there's a big weekend crowd. Often we'll get several observations on the weekend. Maybe as many as, if it's clearly a great powder day or there's a lot to be seen, we might get 4 or 5 or 6, and then a lot of days we don't get any. So on average, maybe a couple a day, some days 0, and some days, maybe 5 or 6 or 7.
And next question is, how do you decide which zone to go to on a given day as a forecaster, and then you might as well tag on there as a recreationist?
Yeah, that's a great question. I like that one. Me personally, I kind of have I wouldn't call it a compulsion, but I really do love to be out in the mountains all the time. And I'm very curious about both snow quality and how the snow's behaving. And I feel like as I get older, the quality aspect is less and less important, and I'm more interested in just watching the snow do its thing. So often, for me personally, on a day off, if I can combine those things, that's where I'm going to be. If I can go ski great powder up high in the mountains in a beautiful spot and collect useful information, interesting information about a question mark that I have in my head, like I wonder if on this slope the sun was high enough in the sky and there was enough opening in the clouds to build a bit of a subtle crust and create some faceting on top of that surface. And maybe I'll go explore that by seeing how good the skiing is there, and find that there isn't a crust, just some subtle faceting, and the skiing is fantastic. So I guess that's kind of my personal answer. For us at work in the Avalanche Center, the skiing and riding quality really isn't that important. That's not our job. Our job is to answer questions that we have. So frequently or always, it's driven by, I wonder, we have X data point here and Y data point here, and there's clearly a change in between those. How do we understand that change? I'm going to go somewhere in between those and see if it's more like X or more like Y, or maybe it's something completely different. So that's kind of how we drive that process.
All right, Jeremy wants to know, how many days a season are you out in the backcountry?
That's a good question. a while ago, maybe 8 or 9 or 10 years ago, I set the goal to ski at least as many days as I don't ski in a year. So, I shoot for that, whatever that kind of that 180 mark, but a little more is better.
More is better. Well, it's no secret that you're out there most days. Okay, next question from Tiger. I understand that routes and terrain come into play, but are there circumstances when AVI danger is so considerable where you won't go out into the field to monitor the pack?
Yeah, that's a great question. And I mean, one of the coolest things, or maybe cool isn't quite the right word, but one great thing about avalanches is they can't happen everywhere. There's terrain where you just don't have avalanches. Terrain that's completely free of avalanche hazard, both on the slope and on the slope above that. So, or from anything that might be above that. So yeah, I mean, even on a day where it's, at a certain point, there's a certain hazard posed by how much snow there is as far as trying to travel through it or something like that. But there are always places that you can go that aren't threatened by avalanche hazard, regardless of the day.
Awesome. Well, please keep firing away questions in the Q&A box. I think we've answered all of the questions so far. There was one that was referring to a different avalanche center about how to make public observations easier for folks to submit. And I think you've touched on the different ways that Sawtooth Avi takes observations from people.
Yeah, we've tried to make it as easy as possible. We've got a phone number you can text observations in. You can just send us photos or videos of what you saw. We've got that observation platform on our website, which is a great way to do it. That has a bunch of forms on there, or a bunch of fields on there that make it easier for you to fill out. They're kind of like how much snow did you see? What was the wind doing? All those sorts of things. You can send us stuff on social media. You can send it to our personal emails, our the info@sawtoothavalanche.com email. Yeah, there's a lot of ways to tell us what you saw. So yeah, I hope that's never a stumbling block for anyone. And if it is, let us know how and why, and we'll work to fix that.
Awesome. There was just a comment in here. It wasn't necessarily a question, but someone was saying how they appreciate this presentation and how it helps people who are going to new zones kind of develop a system to, in a way, be their own forecaster or investigator in that different snowpack. But I thought it was a good tagline into you explaining some of the weekend updates or the conditions blog that people could look to if they haven't been out and about recently.
Yeah, we've kind of tried to address that. A couple of years ago, we started doing what we call the weekend update. And the intention of that is not to replace the Avalanche Forecast, but it's to kind of help you get caught up. If you're coming here from a different area, or you don't have the opportunity to be out in the mountains every day, which is true for most of us. You can see, in that we try to cover what the weather did over the week, what sort of avalanche activity we saw, kind of the trend in avalanche danger. Did it snow a bunch and we went to high danger, and now we're a day out from that and the avalanche danger is coming down a little bit, but there's a lot of stuff to be worried about, those sorts of things. So that's hopefully a useful product for people. And we put that out every Friday, sometime in the afternoon or evening, depending on how late we're out in the field that day.
Awesome. Somebody did ask if this recording will be available, and the answer is yes. We will have all of the Digging Deeper series presentations recorded and uploaded to our YouTube. So this one should be up within the week. So you can rewatch it or share it with other people that you think would appreciate it, or could use listening to some of Ben's insights. Let's see, last question that's in the queue. There's still time if anyone has something on the tip of their tongue, comments, questions, anything like that. But Raina would like to know, What's the long-term outlook for Freshies?
Oh man, that's the big question. It looks a little rough, I won't lie. I wrote in my weather forecast on Tuesday that we may have seen the last significant snow that we're going to see in the month of January, which was a little hard to write and a heartbreaker. My best guess is that we'll see. We haven't really built this really strong blocking ridge that we sometimes set up around here. When we build that, it's just blue sky for days and days and days. But we might be headed towards that. Instead, we've got kind of a ridge pattern where a bit of moisture is making it up and over the top. Sometimes when that happens, we get a little bit of light precipitation in our northern areas, kind of the Sawtooth and Banner Summit, maybe as far down south as the Western Smokies. But even that is not looking super promising. So I guess my recommendation would be don't focus on the next snowfall because it's going to be a while. Maybe think about some new areas you can go explore. Think about where the sun hasn't got to stuff and where the wind hasn't got to stuff. Don't forget to think about the overlap of the avalanche problems that you might be encountering in those areas. And yeah, maybe enjoy the clear weather and sniff out a new spot and stretch those legs because it's always good to be on the mountain.
Or squeeze the throttle.
Or squeeze the throttle, yeah. Accurate.
You still stretch your legs when you snowmobile.
It's a little easier to blast through crust on a sled anyways.
This is true. Okay, we have another great question that just rolled in. How would you change your approach in decision making when going to a remote part of a forecast region which might not have seen many or any observations this season?
Yeah, that is a really good question. This kind of reminds me of, or makes me think of something known as a strategic mindset, which is this idea of what sort of a mindset are we taking with us when we go out into the field? Are we going out expecting it to be, like stability is improving, we're going to go ski bigger terrain than we have been? Is it the middle of a big storm? We're stepping way back and we're not going to be entering avalanche terrain, those sorts of things. And one of those mindsets is called assessment. And I frequently find myself in that assessment mindset, regardless of what I'm expecting. It kind of links back to this idea of observations where we only see what we decide to see. We don't see things that we don't look for. And we don't want to let ourselves get blinded by that. So to the extent that it's possible, I try to go out into the mountains with a pretty fresh, open set of eyes every day, and have an expectation of what I might find, and that expectation might be as simple as I'm expecting to find something that surprises me, or I'm expecting for the weather to be like this, or whatever that is. But then be open to encountering whatever you encounter, and don't try to explain away little avalanches like, oh, that doesn't mean anything, or don't try to explain away why there's so much more snow in an area than you thought, or so much less snow in an area. Just kind of go out and see what there is to see, and try to incorporate that into your understanding of what the snowpack might be doing, and continue to build your model that
way. Thorough answer, Ben. All right, last chance for questions. You can toss them into the Q&A box, or final chance for raise hand to ask it live. While we wait to see if any final questions come in, I'm just going to share a few upcoming events that the Friends are hosting. First, we have an all-women's motorized level 1 course. It's the Friends partnered with Airy and She Jumps, and we will be doing that next week. So if you know of anybody or you're interested personally, make sure you check out the link in our Instagram bio, or go to the website and you'll be able to find that. And you can sign up by paying just the $205 deposit, and then the rest of your tuition, if you apply for the scholarship, the scholarship is available for every participant if you apply and share why you are interested in supporting the motorized community. Thanks to the Avalanche Alliance for raising those funds, and then the Live Large University for hosting the scholarship. So that should be a great opportunity for any female snowmobilers or snow bikers out there. We have 2 virtual classroom sessions only for 2 hours in the evening on the 18th and the 20th. And then the field days will actually be based out of the Trinity Hot Springs Lodge in Featherville, Idaho. So you'll get to hot spring and ride your snowmobile and learn about avalanches. So it's a big win for everybody. We've got a couple spaces open for that. And then if you're sticking around Ketchum on that same weekend, the 22nd and 23rd of January, Backcountry Magazine will be bringing their Backcountry base camp to the Sun Valley area. And we'll be putting out some information on that and how you can participate coming up in our January newsletter. And that will also be put out on social media and on the website. But there's going to be some workshops on rescue and much more. So stay tuned for that. Then the next Digging Deeper is January 26th. So it'll run every other Wednesday. And that one we will announce the topic soon. I believe those are all of our January upcoming events. But we do have some big announcements coming from the friends that I can't share yet. But if you'd like to find out, make sure that you sign up for our monthly newsletter, The Slough to Know. You can do that on the website at sawtoothavalanche.com. Scroll to the very bottom and you'll get subscribed to our newsletter and also the daily Avalanche Forecast to be sent to your email every single morning. So you can't miss the forecast if you do that. And we will also be having our Avalanche Rescue Practice Challenge coming up again soon. We're going to launch that on social media where you will have the chance to win some prizes from some of our sponsors and Avalanche Center partners by just sharing on social media how you're practicing your avalanche rescue skills. So lots to stay tuned for. There's some other exciting events coming up in February, but try to keep it concise for January right now. Again, we appreciate everyone for tuning in. Be sure to follow us on social media at Sawtooth Avi and on the website for those upcoming events. And I will let Ben say some final words before we say see you later.
All right, throw me under the bus there, Amy.
Yeah,
well,
I'll let you goodbye.
Yeah, thanks so much to everybody for showing up and listening. And if you have any more thoughts or questions or ideas, reach out to us at the Avalanche Center. The account that all of us use is info@sawtoothavalanche.com, and you can email me at ben@sawtoothavalanche.com if you've got questions or comments or anything you'd like to follow up on. And yeah, thanks for listening. Thanks for reading the forecast, and yeah, hope you have a good dry spell and that more snow comes soon.
Yes, and one final thank you to Ski Tech for being our virtual sponsor for tonight. If you go in there and you're looking for new liners, you can say that you watched this presentation and they will give you 10% off of some new liners. And we really appreciate everyone at Ski Tech. So thanks for watching. Thank you so much, Ben. And you can check out this recording on YouTube later, and we'll see you out there.